Good morning, everyone. This is Mike Lineker, and today we're going to be discussing differential item functioning, DIF, and how to do it with Winsteps. First question, what is differential item functioning? Well, we have a sample of persons responding to a set of items, and then we have their overall performance. Each item has an overall difficulty. Each person has an overall ability, but in the sample there are two or more groups of persons. Each group has an overall average ability. One group succeeds more on an item. By itself, this is not DIF. The question is, did that group succeed more or less than we would have expected based on their overall performance of the people in the group and the difficulties of the items? If they didn't, then there is a change in the item difficulty for the group, and that is DIF. So, groups always perform better or worse than expected on an item. So, consequently, when we are choosing and reporting DIF, there are two things to consider. One, that the DIF is not likely to be due to accident, to chance. In other words, that the DIF is statistically significant. And the other aspect is the DIF must be big enough to make a substantive difference in performance. A difference of 1/100th of a logit isn't going to impact anything. But a difference of 1 logit would certainly reflect a considerable change in performance. In fact, 1 logit is often equivalent to 1 year's growth in educational settings. A couple of things about words. The majority group in a DIF study is usually called the reference group, and the other minority groups are called focal groups. And what usually matters is DIF against focal groups. In other words, the perception that a focal group is being disadvantaged by an item. Other questions that come up about DIF: how many people do you need in order to do a DIF study? Well, if you want to report a definitive DIF result, the sort of thing that's going to get published in the newspaper, then you definitely need 1,000 people in a group. And if you're comparing a reference and focal group, at least 1,000 in each. Even then, false positives, in other words, false reports of DIF, are common. And if you're doing a pilot study, then you at least want 30 in a group. With 30 and you report DIF, you probably feel, I shouldn't take that item, I should reject that item. Now, DIF can be looked at two different ways. It could be change in item difficulty for the persons, or change in personal abilities for the item. That's your choice. The usual choice is change in item difficulty. There are a couple of other aspects to DIF. There's differential test functioning. If the test as a whole, in other words, all the items respond differently for one group than for the other. In other words, for instance, the test discriminates more strongly between high and low performers for one group than for another group, then we probably got differential test functioning. The problem isn't the individual items. The problem may be that one group of persons is thinking of this test as a high-stakes test, but another group is thinking of it as a low-stakes and aren't really paying the same amount of attention to it. The reverse, one could say, of differential item functioning is differential person functioning. This is useful when we want to examine an individual person to see if they're strong or weak in particular areas. And so with differential person functioning, the items are grouped and we can draw a profile for each person of their performance on each subset of items. And then there's differential group functioning, which is groups of persons with groups of items. For instance, did the boys do better on the mechanics items and the girls do better on the cooking items? Now, in modern society, one would say, oh no, they wouldn't, but that would well be a differential group functioning analysis. Now we're going to do a worked analysis with Winsteps. In the Winsteps examples folder, there is example0.txt. This is the Liking for Science survey. It has 25 items relating to children's perception of how much they like scientific activities, and in the person labels, gender, column 1 is the gender. These have been assigned arbitrarily. We have no idea what the genders were of the original children who responded to this survey. The survey data is real, but the person labels are artificial. So we start by doing a standard Winsteps or mini-step analysis. And let's jump ahead to table 28, which you can get from the output tables menu. And if we use the P subtotal equals outside gender, gender has been set to point to column 1 of the person label, then we get subtotals for each of the groups. The first line has an asterisk in the code on the right-hand side, which means this is the report for everyone, and down below it are the code for F, the girls, and M, the boys. And we notice that the girls have an average performance of 1.62 logits, average ability we could say, an average likability for science of 1.62, and the boys only 0.76. Now this difference is not DIF. This is just the fact that this group of girls like science more than this group of boys. Now we jump to table 30, and we're just going to look ahead to table 30.2. Now we're at the item level, and this table reports the performance of the boys and the girls on each item in a specific way. It says, what was the average rating? The ratings in this particular case are 0, 1, 2. What's the average of the boys and what's the average of the girls on the watch birds item? If we take the first one, and we see it's 1.61 and 1.39. So the girls did liked this item more than the boys did. No problem so far. The problem comes when we compare that column with what we expected based on the overall performance of the girls and the overall performance of the boys and the overall difficulty of watching birds. And here we see the girls are 1.59 average expected rating, and the boys are 1.40 average expected rating. So the boys are a little higher than we expect, and the girls are a little lower than we expect. Okay, that difference is so slight we wouldn't bother with it. But going down to the next item listed here, which is item 5, fine bottles, the story is different. What we observe is 0.44 for the girls and 0.48 for the boys, which is almost the same. But what we expect is 0.73 for the girls and 0.39 for the boys, which is noticeably different. So jumping over to the diff size column, or maybe we should stop off on the diff score column first, the diff score column, we see that the difference between the observed and the expected for the girls is minus 0.29. They're about a third of a score point less than we expected to see. But the boys are 0.09. They're doing about the same as we expected. This transfers into a logit difference and a diff size of 1.05. In other words, the item is a logit more difficult for the girls than we expected, and minus 0.33, the item is a third of a logit easier to like than we expected for the boys. So the boys scored high, that makes the item easier. The girls were observed to score low, that makes the item harder. If we add that effect to the baseline difficulty of the item, difficulty of the item for every one, then we see that the item difficulty of the girls is now 3.47 and for the boys is 2.09. So we have a difference, a diff size, and we notice the girls are at 1.05, which is quite a big difference, a logit difference. And the other rule is we want to be sure that this didn't happen by accident. Well, that's done in the t-test, and the t-test result is that the student's t is 2.17, and this corresponds with a double-sided t-test to a probability of 0.0458, which is less than the normal threshold probability of 0.05. So this difference is statistically significant. So if our sample size was big enough, we would report that this item is significantly biased against girls. And that's the sort of item that always causes consternation and gets the lawyers excited. So that's a simple report on the performance of this item. Now, another way of looking at this, we've been looking in this table, table 30.2, of the performance of the group against the performance of everyone. But what if we want to compare the performance of the boys and the performance of the girls? Of course, we can also contrast the males and the females directly. And this is the traditional way to do diff analysis. One group is labeled the reference group. It's usually the bigger group, or the perceived to be advantage group is the reference group. And the other groups are called focal groups, and they're usually smaller and perceived to be disadvantaged. So here we have the numbers for the females contrasted with the numbers for the males, and the numbers are the same, but when we move to the right-hand side, we can see that the t-test is different because we're contrasting two groups rather than one group against everyone. And here now, when we contrast, particularly on the second line, the females against the males for fine bottles and cans, just below the orange box on the right, we see that the probability is 0.0176. So this difference has now become almost highly significant. And the actual difference between the boys and the girls, we can see below in the diff contrast column, is now 1.38. So that is a big difference, well over a logit difference between the boys and the girls. Here we see the same paired comparison between males and females done using the conventional and widely accepted diff tests called Mantel-Haenszel for dichotomous data and Mantel for polytomous data. We can see here that the comparison produces a chi-square statistic and the probability of that chi-square. Now these numbers will be a little different from the Rasch numbers we looked at because the data are so thin and the distribution is skewed. But in general, for large data sets, the Rasch and the Mantel-Haenszel and the Mantel will give similar numbers. In fact, when they disagree, that leads us to doubt both methods. When should I report this diff? This table is from Educational Testing Service. Rebecca Swick, who's really the expert in this area. And following this table for size and significance, reviewers and others are very unlikely to object to it. So this is, if you need to say, well, has this got diff or not that's reportable, you can follow this table or similar tables in ETS related publications. Returning to table 30.2, which lists the statistics for each group separately, and the comparison is to the overall of all groups, Winsteps produces convenient Excel charts on many of the columns of statistics, and these are illustrated here. If you look on the plot on the right side, you'll see there are three lines. The black line is the girls, the red line is the boys, the females and the males, and the green line is everyone together. Now, a convenient feature of Excel is if you want to get rid of a line, you can click on it and delete the line. So we could easily convert this plot to just boys and girls. Various statistics that are plotted, they're listed on the left-hand side. The DIF measure, which is the overall difficulty of the item for the group. The change in the difficulty for that particular group, which is the diff size. The diff t-value, which is a surrogate for the probability of the diff, and the diff score. Now, it's even better if we reorganize that previous chart a little bit and sort by the group we're interested in. And we can do that because we're in an Excel spreadsheet at this point, and there is a worksheet connected with it. If we sort the worksheet, which is shown on the right, the worksheet tab at the bottom of the Excel, beneath the Excel chart, if we sort it by girls, by F, column F, we get the plot that you can see on the right here, which shows how the girls are finding items from the easiest to like, which is go to the zoo, to the hardest to like, which is the find bottles and cans, and superimposed on the girls are the boys, the red line, and we can see how they relate to the girls. And it's jagged. There isn't any consistency in this particular plot. If there was consistency, then we might be having a differential test functioning. One, the boys might not be taking the test as seriously as the girls, the survey, but in this case, there's not really any evidence of that. We can also cross-plot the measures for the boys and the girls. Also an Excel feature. And this shows us which items are different for the boys and the girls and whether they're significant or not. So items outside those confidence bands, which are only approximate, but outside the confidence bands, are the items that are unlikely to have happened by chance, and the difference between the items can be read between the difference between the values on the horizontal and the vertical axis, the x and the y axis. Now a quick look at other things. Here's the same thing as diff, only for the persons now, differential person functioning. It operates the same way. We put a classification into each item label and then summarize each child's performance in each group of items. And this enables us to construct a profile across the item groups for each child. And that's shown at the bottom of this PowerPoint slide. We can use the Excel to plot for each child, and if you want to have a separate plot for every child, then you can do that from Excel. And for the instructions of that, go to our dear friend Dr. Google, who will explain how to set up a keyboard macro so that you can draw and output one Excel plot after another. so you can then include them in an overall report or a report to each parent or whatever is the application that you have. Winsteps also can produce differential group functioning, table 33, where we can get a profile of the performance of each group of persons on each group of items. Here there isn't a baseline measure, there's just a difference, a DGF size. This is because each person in the group has a different ability, each item in its group has a different difficulty, so all we can report is the overall shift. And that's what table 33 does. So thank you for joining me in this adventure of examining DIF.